today's session, it's going to be more of a concept oriented.
Hello.
So all the concepts that are required to understand level of detail calculation. Saying is, from no one will calculate on table calculations. Today's session is specially focused on helping us understand why we require LOD expressions, what are the basic concepts that we need to know to understand the level of detail calculations. We'll explore them, and then we'll see what different types of LODs we have in Tableau, and we'll see quick examples on each one of them. And in upcoming sessions, what we'll do is we'll explore these individual LOD expressions in detail. Let me know if you have any questions on understanding any certain concept in today's session, so we can clear that out. Okay. So before we start getting into LOD calculations and expressions, we need to understand two things in Tableau. That is granularity and aggregation. So what I mean by granularity and aggregation, let me just open a new sheet. So I'm using global superstore data, and if you see here, let me actually go to the sample one, and I'll just drop sales into text. Okay, and it's giving me overall sales for all the years, all the products, everything. Now I can you might be familiar with all these basic concepts, but just to keep the transparency among all the candidates, I'm just briefly going through all these things. So I have a category, and I've created already a hierarchy for all these things. Now my overall sales is split up in these categories. As I drill down, my sales is split up into different products, manufacturer, and etc. So what I'm doing here is I'm at this level. At this level, I'm seeing the data at a highly aggregated level. So my aggregation is to the topmost. Do I have any details? Like, for example, from this number, I cannot tell, hey, what are the sales in category furniture? I cannot tell that. What are the sales from the state of, let's say, New York? I cannot tell that. So the details are missing here. So this is low level of detail. So we don't have any details here. But when we go across this, when I add a category, I have some amount of detail. I can tell sales at a category level. So I have some amount of detail, and I'm increasing in level of detail. So my level of detail is increasing. This is also called as granularity. So my data is getting more granular and granular. My overall sales is getting split up into at the granular levels. So each of these things that we see, the level of details is called the detail thing is called as either it's called a granularity or a level. Now, correspondingly, your aggregation keeps on changing. So for example, here I had a higher level aggregation data. I have lower detail and higher aggregation. When I go deeper into aggregate level of detail or more granular, my aggregation tends to decrease. My aggregation becomes lower aggregated data, and likewise, and so on. So there's a chart that's simple. So this particular image will explain the same correspondence between granularity and aggregation. So think of it as this way. So I will come to which level detail and etc. So at this point in time, let's assume there is some measure that we are looking at, and that is viewed at a dimension 1 in certain dimension. Upon adding dimensions, okay, my granularity is increasing. My granularity increases, and when I have less, so that is the level of detail increasing, and when I have less number of dimensions or no dimensions, my aggregation is high, my aggregation is more. So I'm going down in aggregation, and I'm increasing in granularity as I keep on adding my dimensions to the view. Let's come back to this in during the session. So that's clear, right? So the aggregation and granularity. Now let's take a look at some example using the granularity and aggregation that we just saw. Most of you might be familiar with this, but again, just to keep transparency, I'm going through this. Now I just wrote a simple calculation field. So in the data I have, what I have is, I have sales column and I have a profit column. Okay, if I go to the data source, again. Okay, as you can see the data here, here we have each row. So this, why I came here was, we have to understand, we broadly saw there are different levels of aggregation on the demo that we just saw, and the data source itself is at a certain level and that cannot be changed. So that is the level. So for example, each row here represents we know this dataset very well. So what it is it's a particular product in a certain order. If so that represents a certain row. So that is the level of detail of the data source. So that is one thing that we need to remember. So all of the calculations that we write without using LOD expressions will be done at the row level. Those are called row level calculations. So that means they work at the level of detail of the data source. Whatever the detail that the granularity your data source is at, your calculations will work at that level. So I wrote a profit ratio calculation. It's simply, can you guys see the calculation?
Yeah, we can. Profit by sales.
Yeah, it's simply profit by sales. Now it's doing that for every, since I didn't mention any level of detail using LODs or anything, it's just calculating for every row. Now here I have another calculated field edit. I just modified it in a certain way that before, instead of mentioning profit by sales, I mentioned some profit by some sales. So what I'm doing is, before you divide these two things, just aggregate them and then divide it. So at this point, since we are looking at a row level, so the values are same, because here the profit is only getting one row, and some sales is also getting one row, one value. So these two values match. Now let's go to the sheet. Now here I have a simple setup. What it does is, I have both the calculated fields here, and let me go to a level of detail of data source. Okay, this is my row ID. So each row is a particular row in a data source. So all my values match up. So this calculation and this calculation matches up. Now, but when I drill down to subcategory, if you can see, my ratio is never supposed to go across over 1. So but here, where we didn't provide the aggregation, you can see it's just crossing 1 and it's giving us stupid values. These values doesn't make any sense. So it's because of the aggregation, order of aggregation. So here what it's doing is, basically it's calculating the ratio and then aggregating on the top of that. So all the numbers that we saw, for example, these numbers, it's calculating these ratios and adding all these things, and thereby, so it's a 0.2. That means if you have 0.5 0.2s, it will simply cross 1. So that's not, that's why we are getting numbers that are greater than all these numbers. But here the order of aggregation is reversed. We are not aggregating, so we are not calculating the ratio directly. First we are aggregating and then calculating the ratio. That's why ratio is always less than, less than 1, and this is the right number to see. So yeah, so one thing is, so this also brings us to another concept. We just saw level of detail of the data source, right? Now this number, what is this number? This number is being calculated. I know this is aggregated, but at what level it is aggregated at? It is aggregated at bookcases level in furniture, and likewise all other categories. How does it how does this calculation know that it has to aggregate at a bookcase level? There is other this brings us to the first level of detail, which is Viz LOD. So it's called a Viz LOD. So your whatever the visualization that you make the view, it will be at a certain level of detail. Here the level of detail of the visualization is at the bookcase. So it's basic aggregation and calculating all these things at the level of detail of the view. So far we have two levels. One is data source level and the Viz level detail. Now what if think of a situation where...
One quick question, Jagdish, sorry to interrupt you. So, so are you saying that whenever we write a function, a calculated field, it is always at a level of detail of the Viz? Is that what you're saying?
No. So we just saw two things here. It will, if the calculation will work at the level of detail or at the data level.
At what?
In the data source, as we saw here, profit ratio, at the level of detail of the data source.
Okay, got it. At the level of detail of the data source, that's what it. Okay, got it. That's why you have the sum profit aggregated into more than one, right? So that is one. But this one, so what you have here, this did not
here it was
aggregate. Okay, and but here it is a simple formula, right? Which is sum profit divided by sum sales, right?
Yeah,
so
it's just the
aggregate.
It's just the difference between these two is it's just the difference in the order of aggregation. Order of aggregation here, what we are doing here, if you can see here, we got sum of the ratios, but we are not taking the sum of ratios. We are actually summing them first and then taking the ratio.
Got it.
If you see this number and this number,
so
both.
I'm trying to understand what.
Go ahead.
No, I'm just trying to understand what is the underlying principle that we should take away. That's what I'm trying to get at.
So the first thing to take away from this point is to understand that there are two levels. One is the data source level, and there is a view level. View. This is also called LOD, view level of detail. And the other thing to take away from is the order of aggregation matters. If you aggregate first or later.
Okay, excellent, perfect, got it, understood.
So
when you did aggregate, right? I think maybe one thing here is when you did aggregate, which is sum profit divided by sum sales, right? And then you did so at that time it will show at the level of Viz. Is that a takeaway that we can? I'm just trying to understand.
Both of them are currently showing at the level of detail of the Viz only. So just because the first column is showing wrong values, we cannot say that it's not working at the level of detail of the view. It is working at the level of detail of the view, but it's just showing the number at which we are not interested in. It is not the right number.
Got it.
So if you see what this thing is doing is this number is getting by after dividing this by this, which is what we want, which is sales of this bookcases. But this number is something else, which is got actually by dividing. If you see, so profit ratios. So for each row level, you understood, right? So basically,
I got it. I got it.
So both of them are working at a level of detail of the view only. By default, whatever the calculation that you put, if it is aggregated in the calculation itself, it will work. It will work at the level of detail of the view. If it's not aggregated at the level of detail, by default Tableau aggregates it. If you can see the sum here.
Yes.
By default, Tableau aggregates it to the level of detail of the view.
Okay. Understood. Yeah.
Okay. So we have, yeah, so we have overall data source level. Now what we can do is, let's say now LODs comes into picture, fixed, include, exclude, they come into picture when there is a certain scenario where you want to keep the view at a certain level of detail. You don't want that level of detail of the view to be changed, but you want the calculation to be occurred at another level of detail apart from the row level of detail, which is at the data source level. If it's at the data source level, you don't have to need any fixed or include, exclude. But if it's excluding either of these two levels, not the data source level, not the view level, then without using include, exclude options, you cannot get that. So from Tableau version 9, what they did, they introduced something called these LOD expressions, fixed, include, exclude, and using that you can calculate a calculation keeping the with the different level from your level of detail of the view or the data source level. And let me just open up a page. Okay, great. So this is the so we have in total 3 level of detail expressions. This fixed, include, exclude is called fixed level of detail expressions, not the level of detail themselves. And we have 3 types of expressions. One is fixed, include, and exclude. Now this is the typical general syntax that follows for all these expressions. So we're just looking at a fixed one. We'll come to the others when required. So if you see here, we have 4 main parts. One is the scoping keyword, which is your level of detail expression itself, and then for which dimensions. Basically, this is the level at which you want the calculation to be calculated at. You'll specify here. If you have multiple, you can just put a comma and do that. Then you have what measure that you want to calculate, and by what calculation you want. You want a sum or minimum or count distinct or etc. So this itself gives you at that level calculation. Now I have put a small example for us to understand what's happening here. So yeah, so this simple view, what I have here is I have for every country, I've just dropped my average sales. Simple, plain simple average sales. Now in US, I can see my average sales is around 230. Whenever we have a calculation, it occurs at a certain level of detail. And at what level do you think this particular calculation is happening? So far we have discussed data source level. And so can anyone think of anything like how this number is achieved?
I think it's currently happening country level, since I can see the countries dropped in detail.
Correct. So for each country, I have a value exactly, right? So if we go into a certain country, let's say US, okay, this 230 number. So at this point, I'm only looking at US records that are belonging to country US. Now, how from those records this particular value is achieved? What's Tableau doing behind to get this value behind 230?
It's adding the sales of that country and doing an average of it. Total number of records for that country divided by the total number of sales.
Okay, so yeah, so total number of sales from US and divided by number of records. Is that what you're saying, right?
Yeah.
Okay, yeah. So that's right. But that's true. So it's working at a row level. So it's dividing by number of records. That's why it's working at a data source level of detail. That's why it's taking denominator as number of records. But let's say we don't want that. We are interested in seeing a value. Hey, for each country, give me average sales value in a state. So for example, what is the average sales value in US state? I want that to be displayed here instead of a row level calculation. So we know the calculation how it should proceed. I should simply get the sum of sales of US and divide by number of states. That's correct. That will give me average sales value for a particular state. Now how do I get that? So I've so if you see here, I wrote a simple calculation using my fixed LOD. Let me open fixed sales. Can you guys see this? Okay. So what it's doing, let's I have two fixed LODs here. First, let's see what's happening there. So since I need a calculation to work, at a no, I want my calculation for every country, but I need the sales of each state, right? So what I'm doing here is basically I'm getting fixed state sum sales. So what it gives me is for each state, it will give me some of the sales. If you guys are familiar with the group by function in SQL or Python or R, this fixed state is similar to that. What does group by give us is whatever the group by field, and it will aggregate rest of the columns that we want to that field. So currently it's doing the same thing. So each fixed statement thereby generates a certain table behind. So what this fixed statement that is highlighted will give is, for each it will give each record as a state and the sales in that particular record as a value to that state. So this table we got. Now we are taking average for each country on a country level from this table. Instead of taking from the data source table, which is at a row ID level, now we created another temporary table which is at a state level with the sales in it, and we are taking average on this. So it's very similar to the one which we saw earlier where we got average sales simple. We are now creating, just added a new table and we are taking average on that. Thereby what it's giving me here is okay. So yeah, if you focus on US, the value is 46,882. So what is this value? This value is the average sales value in any state. You understood the difference between the first one and this one, right?
Yeah.
So yeah, so fixed level of detail is we can use them to create this type of calculation. And let's go to example on the include one. Okay. Yeah, let me region. So let's create here. So here I have a simple view which says gives me average sales for each region. Okay. Now this average sales is similar to one we saw earlier. It works at a data source level. So basically it divides this by number of records in North Asia region as numerator as a total sum of sales. This we know, but let's say I want to know average value of average order value. Okay, average order value in this particular region. Instead of row level, why order ID is different from row level? Because a person can order a single time multiple products. So all these multiple products will have single order ID but have multiple records. So row ID is not same as order ID, and I want the value. So what is the average order value in each of these regions? That's what I'm looking at. And when I put average sales, the value that it is giving it is a row level, so it's not the value that I want. So how do I get the order ID level? It's simple. First thing, I need to understand where my view is at. So what is my level of detail of the view? My level of detail of the view is each region. I don't have order ID. Okay. What I can do is I can create a calculated field that says include is something that adds an additional dimension onto the existing level of detail of the view. Let me just yeah. Can you guys see this image?
Yeah.
So what it's doing here is you have a WIS level of detail. My WIS level of detail is region at this in the current example that we are going through, and these are the dimensions that are used to get to the WIS level of detail. Okay, and this is the dimension that I'm including using a include expression. Okay, so my calculation will occur at this level. Though my WIS level is at this level, I'm including this dimension with the include expression, so my calculation will aggregate at this level. And after getting the calculation at this level, since my I need to show the results that are happening that are produced at this level to this level, so it will aggregate them. It will aggregate them to this level. You understood, right? So for example, here we have at a state level, and here we are doing calculation at city level. I cannot put the city level calculations in a state level. I need to somehow aggregate them, either minimum or average or sum. Then only I'll be able to pull this value at a state level. So what it'll do is calculate the value at the next level and then aggregate them back to the WIS level of detail. So that's what we are doing here. What we need here is we need order ID to calculate the average and put them back to region level. So let me open the calculation field quickly. So I've just included order ID and give me some sales. So for in each region, it'll create a table in each region for all the orders that are emerging from that region. It'll create a sales value, that simple table, and after that table is done, my aggregation is important here. So since we just saw, I'm using average aggregation, and it's from that created table, it's taking the average value and giving me this number. So this would be the value that which we are interested in. So the average value of the order, any general order from this region. Clear, right?
Jagdish, I have one question here.
Yes.
So currently we are using include order ID average sales. What will be the result if we use fixed order ID average sales? Mostly same, right? Or will there be any difference?
Fixed order ID average sale. I think okay. Let me actually. What you want to change? You want to fix it order ID?
Order ID, some sales, yeah.
Some sales. Okay.
So Jagdish, just make a copy and edit now, so that way we can compare both. And
Yes.
Yeah, it's same, right? Yeah.
It happens that to achieve a certain number, we can there could be multiple processes. Okay,
Yeah.
but the difference between fixed and exclude, there is a significant difference that to be considered between fixed and exclude in terms of filters and other things. We'll come to them in the later session, but it's not. You shouldn't be surprised if the same calculation can be achieved using fixed or include or exclude.
If you could see West and Caribbean, the numbers are different.
Where?
West and Caribbean, yes, for those two. It's 450.3 and 456.
Is it? Yeah. Okay, I'll take a look at them and I'll come back later. Yeah.
Yeah, sure.
And next we have the other exclude LOD. So I'll another view to explain the same. I have my sales split up across each month in each region. So in central region, in the month of January, these are the sales that happened across all the years. So likewise for all the regions and months. Now let's say I want, if you can see here in the tooltip, I'm comparing the sales value for January in central region with the overall sales. Okay, and how do I achieve that? How do I get the total sales? One way is I can write a fixed LOD at a January level, okay, and get the total sales. So that will give me for in the month of January what is the total sales that happened. So I can easily compare. We can do that as well. So other thing that we can do is we can use exclude expression. I wrote this simple calculation which so what is my level of detail of the view? My level of detail of the view is 2 dimensions, which is region at a month level, each mark at a region set in a particular month. So now I want my total sales. If I want to get total sales, I just need to remove region level of detail. So that will leave me with only month level. So my sum sales excluded region detail will give me sales that happened in the month of January across all the years. So that's what exclude expression can do. So from the level of detail that has in the view, you can exclude one or more dimensions or the details that you don't want, and then perform the calculation at that level. So here we are doing a calculation. This means basically we are doing calculation at the month level, and then we click OK, and so that value is shown here as 94,925. It remains same for as long as we are on the same month, since the calculation will remain same. This one is clear, right?
Yeah.
Let me open this one as well. So yeah, this is the excluded one. So basically here the visualization level of detail, it will exclude one particular level of detail, and whatever the value that is there, if it's just as we saw, it will duplicate that value to the all the regions as we saw here. So the same value, that 94,000, is duplicated for all the values, so it will duplicate it.
Okay, just to be clear,
Yes.
94,000 is the sales of January.
Yes.
It's not divided by the region.
No, it's not divided by region. It's the sales that happened in January month. Give me a second.
But why the graph lengths are different in every?
No.
Currently the graph, yeah.
The value, the bar length of the bar graph is only plotted using the sales value, that is taking into consideration both central region and the month. It's not the total value. If I put the total value exclude sales, it will be same. So the same length. Understood? Huh?
Yeah.
Okay. So this is so basically to introduce you to this level of detail of expression, we'll go in depth of these detail expressions and how they differ from each other, and how filters affect each of these things in the upcoming sessions. And here I have one more example of the fixed level of detail example. So I'm actually running out of time. So here what I did was, for each customer I just need to extract when that particular customer has joined. Okay, so if you can see, this particular customer ID has given orders in these years, 2011, 2013 and 2014. All I need to extract is what is the minimum value of these values, so that I can get that value, that I can consider that value as that's the first year in which this particular customer ID has given a certain order. So that will be his joining year. So I can use a fixed expression. Can anyone want to try, like how the calculation should look to achieve this kind of number?
Fixed cost.
Minimum order date.
Let's go with fixed expression.
Fixed customer ID, minimum year of order, the order date.
Correct. So for each customer ID, it will look all the years in that customer ID has, and will give you the minimum of that. So fixed customer ID, minimum of year ID. Yeah. And there is one more thing that I want to discuss and close today. So the fixed and this level details, there is a small catch. It's I know many of you would know it, but I just want to mention as it's important. So here the Viz level is at a city level. Viz level of detail is at a city level, and I created a simple calculation. Fixed state, right? Fixed state level sales. I created a calculation at a state level to give me return the sum of sales. Now my level of detail of the view is greater than my level of detail of the calculation. Okay. That's why what's happening here is, here we have state and city as a single value, but if we go to these examples where we have multiple cities in a state, the value is duplicated, as we know. Okay, here my level of detail of the view is greater than my level of detail of the calculation. When I reduce to state level, my level of detail of the view and calculations are same, so these numbers are same. When I go back even to at the country level, my level of detail of the view is greater than my level of detail of the calculation is greater than my level of detail of the view. So it's basically aggregating. Here it's aggregating when my calculation level is greater. Here it's when both are same, it just gives me duplicate same values. When my calculation level is at a lower level than the view level, it duplicates. This is something it can help sometimes. So so this is basically today's session. I just wanted to introduce you to all these different levels and aggregation types that we have, expressions that we have. From next session, what we'll do is we'll dig deeper between the differences between these and when to use which of these things, and what are the advantages for each of these things and different scenarios, etc. All those things. Any questions in today's sessions so far?
So Jagadish, okay. So you don't necessarily have to answer this now. If you want to answer it in the next session, that's also fine. So in this particular case, as you're showing the example, right? So I understand that. So you have used fixed LOD here, right? State
Yes.
level. So at a fixed level, at a state level or above, it has duplicated both the numbers between sales and fixed state level. But when you went to a lower granularity, why does it still have same numbers? So for example, so you understood the question? So see here, I understand that okay, these two are same, like 925, 925, they're same, that's fine. Because this is at a higher granularity, okay? But when you, but even here, I'm not sure what it means when you say fixed state level, but we are showing at a country level. But when you go to a lower level of granularity, just click on, So when you do this, so these numbers are showing same, both, in fact, they are showing same at all points in time, is it?
No. So here we only have one city in a state. Okay, that's why at a state level calculation it's same. So if we can have to see cases like this, let's assuming that there are multiple cities, then the value is duplicated.
Acha. Okay, understood. I think this is clear. So this, got it. You go for, so there is no further granularity, is it, at this point in time?
If we go, let's say,
Jagadish?
Yeah.
If you see that, last row, which is having different numbers as such, like 653 and 1287.
My sales. So my sales is fixed state level. State level sales is showing 1287. Strange.
Jagdish, you can check this later when you have more time, and then you can get back. I'm sure there are some intricacies there that you need to understand.
I asking actually some questions. Is it the same question like when these values will duplicate?
Correct. Yeah, exactly. Yeah. That was the question actually.
Okay. Yeah, no problem. I'll take a look at why these values are different. Actually, they should be. I'll take a look and I'll come back to you.